section 4 from page 50 onwards deals with percentages and ratios again. Remember, percentage, ratios, proportions, fractions and decimals and percentages, all this kind of stuff. I said percentages twice, didn't I? What this does is occur in Unit 1 and 2 and 3. It goes right across the whole of the curriculum. So here it is, a little chapter on percentages and ratios again. And question 1 says, use multipliers to increase such and such by whatever. So let me just do an increase. I want to increase 80 kilograms. I want to increase it by 70%. Okay, fine. So that means I'm going to take my 80 kilograms multiplied by 70 plus 100 is 170%. That's what an increase means. So it's 1.70. Don't need a 0, but at least you feel happy about having the 0 on the 70 represented there. So then you pick up your machine, and in one step you just go 80 times 1.7, and that will give me 136 kilograms. That was an increase. Let's just do a decrease. I want to decrease 37.5 litres of I don't know what by, so reduce it by, getting glitchy, by 12%. Well, if I'm reducing by 12%, I must retain 88% of my original volume. So here I go. So I'm going to go 37.5 multiplied by 0.88. That's 88%. And let's just go for it. So 37.5, hit the wrong button, multiplied by 0.88. Now of course you can work out 12% of 37.5 and then take it away. You're asked to use multipliers, so let's just do that. Answer 33 litres, and that's that one, and that was that one. Done. End of it. You get these. We've got these old-fashioned VAT ones when it used to be 17.5% in the good old days. I've got a microwave which I couldn't bother to draw. Anyway, it's a microwave. It costs £79.99p, and I want to add on 17.5% value-added tax. Now, if you're going to add on 17.5%, you're going to add it on to 100% of the original. So we're going to then add on 100% onto that. So it's 117.5. So I'm going to take my 79.99 and add on, and it's not add on 117.5%. In other words, multiply by 1.175. Remember, 17.5% means 17.5, and percent, so hence 1.175. Very important using multipliers. So let's just do that. 79.99 multiplied by 1.175 gives us, and I better do this to nearest penny, otherwise it won't make any sense. So we've now got a price of £93.99, because it's 93.988, and this 8 will push that 8 up, so that's correct. Alright, so let's just write it here what it was. So 93.98825. Now money does not look like that, does not, does it? That's where it stops, and that 8 will push that 8 to a 9. Just a bit of revision there. So 2dp, no more for money. And that's question 1, and we've got and question 2. We've got ourselves a grade D. Well done us. Now question 3 is proper grade C, because it involves a successive percentage change. So Zoe invests £2,000. So we're chatting money now. In shares. In the first year, the shares go up by 9%. So increase by 9, and in the second year they go down by 4%. So down by 4%. Okay. How much is Zoe's investment worth after 2 years? Now, if I'm going to go up by 9%, I need to multiply by 1.09. If I'm going to go down by 4% next year, I still have 96% of that original price. So, well, the price of the year previous to that. So that's going to be 0, please work, 0.96. So I multiply year on year, and that's my original £2,000 investment in shares. And the question says, how much is Zoe's investment worth? In other words, final answer, not how much she's made or how much she's lost. So 2,000, multiplied by 1.09. That takes care of the 9% increase. I hit equals there. Doesn't ask me to work out what happens after 1 year. It's after 2 years. And straight away I'm going to multiply that answer by 0.96. And that gives us an answer of £2,092 and 0.8. But please put a 0 because this is money, and remember you get marks for your quality of your written communication. Right? If you don't put the 0 there, just because your calculator doesn't have it, you'd get it wrong and lose a mark. Remember, 1 mark makes the difference between one grade and another. That's it. Question 4 is way too much to read, so I'm not even going to look at it. Question 5, I'll do that one. Question 5 is good. There are estimated to be 5,000 trout, that's fish, 5,000 trout in a lake. This number is expected to decrease by 8%. Come on, 8% per year. Right. Then it asks me some questions. How many trout are expected to be in the lake after 2 years? Well, I'm going to take my 5,000 trout, multiplied by, if I'm going down by 8%, I've got 92% still sitting there. So multiply by 0.92. That's 1 year. Now my second year, multiply by 0.92 again. Alright, so no middle answer required. That's obviously after 2 years. So here I go. 5,000 multiplied by 0.92 and multiply by 0.92 again. That gives me 4,232 trout. Alright? Now it says after 5 years. Okay, here I go. So 5,000 multiplied by, going down by 8% each year, so it's 0.92 times 0.92 times 0.92 times 0.92 times 0. I've lost track of it. Essentially multiply by 0.92 5 times over to the power of 5. Save me writing this out 5 times. That's the clever way to do it. And besides, we've got the power button on our calculators. So 5,000 multiplied by 0.92 to the power of 5. Let's just show you, let me tell you what I put into my calculator. I went 5,000 times 0.92. My old Casio has a little hat on it like that. If it would just please write, yeah, little hat button and then a 5. So that means power of 5. Alright, so that's what happened. And don't write this in your exam. Just go bang and then go straight to the answer. And that's what I'm going to do now. Press equals. Look at that. After 5 years, 3,295.4. Forget the 0.4 of a fish. Whole numbers of fish is what we want. That's how many you've got after 5 years. Then it says 10 years. Same trick. Use the power button. Don't write this out 10 times. Multiply by 0.92 powered up to 10. Go straight to the answer. So 5,000 times 0.92 powered up to 10. This is a drop year on year. Here I am in terms of whole numbers of fish. 2,172 approximately to the nearest whole number. Again, these are only estimates. You can't get it bang on. So 2,171.9 fish. Roughly 2,172 fish. All right, that'll do. And then it says 20 years, and then it says sketch of graph. I'm not going to do that. Essentially, graphs, it will go down quite drastically. So that's what I'm going to do. Leave it like that. I'm not going to draw a graph. You can draw a graph in class, but that's all time consuming. Essentially, we're doing a repeated percentage decrease, and that's fine. We'll just leave it like that. I'll pause a minute, just read the next question and see if it's worth doing.